Okay, we're going to talk about something called the limiting reactant. The limiting reactant is the reactant that limits how much product can be made. Okay, so anytime we have a chemical reaction and we have reactants reacting to produce products, you can only produce as much product as the limiting reactant will allow. So this seems to be overly complicated when we're talking about chemistry and chemical reactions, but just think about something that you already know in a daily application. So for example, if you were making chocolate chip cookies and you had the recipe, there would be something that would limit how many batches of chocolate chip cookies you could make, whatever you would run out of first. If you only had enough flour to make one batch of chocolate chip cookies, but you had enough sugar to make 10 batches of chocolate chip cookies, it doesn't matter how much extra sugar you have, you can only make as much as the flour, the limiting reactant, would allow, because once that runs out, you're out of one of the ingredients. And that's all a chemical reaction is. It's just a recipe with ingredients that form products. So let's just do a real generic example before we do any actual chemistry. So let's say I am making a grilled cheese sandwich, and here is my chemical equation for a grilled cheese sandwich. I'm going to say 1 cheese plus 2 bread produces 1 sandwich. Okay, so here's my equation. I'm going to say if 14 cheese and 20 bread react, how many sandwiches can be made? So this seems silly because you can all look at this and see, well, I need twice as much bread as I do cheese to make 1 sandwich. So if I have 14 pieces of cheese, I could make 14 sandwiches. But if I have 20 pieces of bread and I need 2 pieces of bread per each sandwich, I could only make 10 sandwiches. So bread is my limiting reactant because I can only make 10 sandwiches with the bread, but I could make 14 sandwiches with the cheese. So just hold tight, because when we start using compounds and molecules, it seems much more intimidating than it actually is. So let's just do this like this was an actual chemical equation. So here's my mole to mole ratio. 1 cheese to 2 breads makes 1 sandwich. So what you're going to do is separately, you are going to determine how much product can be made with each reactant. So separately determine how much product can be made with each reactant. Separately, individually, however you want to think about it. So let's do the cheese first. Okay, so if I have 14 cheese, the mole to mole ratio for cheese to sandwich is that 1 cheese makes 1 sandwich. So cheese on the top, cheese on the bottom, cheese will cancel. 14 times 1 divided by 1, I can make 14 sandwiches with the cheese. So let's talk about the bread. My mole-to-mole ratio for bread to sandwich is 2 to 1. I have 20 pieces of bread. 20 bread. My mole-to-mole ratio for bread to sandwich is that there's 2 bread for every 1 sandwich. Bread is going to cancel. 20 times 1 is 20. Divided by 2 is 10. I could make 10 sandwiches. So what we've done here is we've determined what's called the limiting reactant and the excess reactant. So in this specific example, the bread is the limiting reactant. It's the limiting reactant because it is the reactant that will limit how much product can be made. Another way to say this is it will run out first. So if you're trying to make as many grilled cheese sandwiches as you can, it doesn't matter that you have 4 pieces of cheese left over. You can only make as many sandwiches as you have bread. Once the bread is gone, you can't make any more sandwiches. So that makes this called the excess reactant. The excess reactant is the reactant you have left over once the limiting reactant has been consumed. So the excess reactant, how much extra, this is the excess reactant, and the amount left over is 4 pieces of cheese. Because I can only make 10 sandwiches. That's all the limiting reactant will allow. So if I need 10 sandwiches, I'm going to make 10 sandwiches. 10 sandwiches, and the mole-to-mole ratio is for 1 sandwich. I need 1 piece of cheese. Sandwiches will cancel. That means I needed 10 cheese. So I needed 10. I have 14. 14 cheese minus 10 cheese equals 4 cheese. So this is what's left over. So I just want you to remember how simple and silly this sounds, because this is all we're doing when we're calculating limiting reactant and we're doing stoichiometry. Instead of using breads and cheese and sandwiches, we're going to have compounds and molecules as reactants and compounds and molecules as products. So let's look at a real example. A non-sandwich example. So let's go back to the example that we did in the last video where we said 2 moles of strontium reacts with oxygen to produce 2 moles of strontium oxide. So this was the formula that we did in the last video. We had 2 moles of strontium plus oxygen produces 2 moles of strontium oxide. So if I say 10 moles of strontium reacts with 7 moles of oxygen, how much strontium oxide can be made? And then I'm going to ask, what is the limiting reactant? What is the excess reactant? Okay. So I have 10 moles of strontium, 7 moles of oxygen. How much strontium oxide can be made? So again, individually, we want to see how much product can we make with 10 moles of strontium, separately, we want to see how much product can we make with 7 moles of oxygen using the mole to mole ratio. This problem has to be balanced for any of this to work. If these mole to mole ratios are not correct, then your answer here will not be correct. So let's do strontium first. So I'm going to have 10 moles of strontium. The mole to mole ratio of strontium to strontium oxide is 2 to 2. 2 moles of strontium would produce 2 moles of strontium oxide. So moles of strontium are going to cancel. 10 times 2 is 20, divided by 2 is 10. 10 moles of strontium can produce 10 moles of strontium oxide. So that's the strontium. Let's look at oxygen. 7 moles of oxygen. The mole to mole ratio for oxygen and strontium is that 1 mole of oxygen will produce 2 moles of strontium oxide. Moles of oxygen will cancel. 7 times 2 is 14. 14 divided by 1 is 14. 14 moles of strontium oxide. So these are the 2 amounts of product that you could make with those 2 amounts of reactants. Now remember, the limiting reactant is a reactant that produces less product. It's the one that's going to run out first. The strontium produces less product, which means strontium is the limiting reactant. Well, the one that's not the limiting reactant is the excess reactant. So that means oxygen is the excess reactant. Something that I didn't mention in our first example, but is also important, I'm going to go ahead and add to my question here. How much strontium oxide can be made? That is the answer to however much you can make with the limiting reactant. So that number, how much strontium oxide can be made, this is actually called the theoretical yield. The theoretical yield is the amount of product that can be made with the limiting reactant. So here, the theoretical yield of this problem is 10. 10 moles of strontium oxide. This is the theoretical yield. The theoretical yield is the amount of product that you can make. The strontium is the limiting reactant. That's what's going to run out first. The oxygen is the excess reactant. That's what you're going to have extra of. If we go back to our grilled cheese sandwich example, so I would say, what is the theoretical yield? So the theoretical yield is the amount of product that you can make with the limiting reactant. We said the limiting reactant was the bread. The amount of sandwiches or product that you could make with the limiting reactant is 10 sandwiches. The theoretical yield would be 10 sandwiches. So limiting reactant, excess reactant, theoretical yield, all of this is important when we start to talk about stoichiometry and calculating quantities in chemical equations.